In this lesson, we've been working with absolute value equations and inequalities, so this tutorial is going to step us through some examples. This first example says, solve the absolute value equation, check your solutions. The equation that we have here is 3 multiplied by the absolute value of the quantity x subtract 15 is equal to 27. So one thing we need to remember before we try to isolate the variable, we need to isolate the absolute value expression first. Once we've isolated the absolute value expression, then we can write a pair of equivalent equations and then use those equations to solve for x. So the first thing we're going to do is divide both sides by 3 to undo multiply by 3. 3 divided by 3 is 1, and so now our absolute value equation looks like absolute value of x subtract 15 is equal to 9. Now remember, absolute value means distance from 0. So your distance can go in two directions. So we're going to have two equations that come from this absolute value equation. The first one is going to be the x subtract 15 quantity, and that's going to be equal to 9. But we also have the opposite version of that quantity, and it's also equal to 9. So let's kind of divide this up and take a look at each one of these equations. We're going to solve for x in each one. This first equation, we have x subtract 15 equals 9. So to eliminate the subtract 15, we will add 15 to both sides using the addition property of equality. When we do that, we are left with x is equal to 24. Okay, we're going to hold on to that for a second. Over here on this side, we have the opposite of this quantity, x subtract 15 is equal to 9. So what we can do is say that the quantity x subtract 15 is equal to the opposite of 9. In other words, we could say we're dividing by -1 both sides, or multiplying both sides by -1. Now let's do the same thing. We'll isolate the variable by adding 15 to both sides to undo the subtract 15. And when we do that, we get x is equal to a -9 add 15 is 6. Okay, now let's do a quick check of each of these solutions. Starting with x is equal to 24. So we're going to substitute that value back into the original absolute value equation. So we have 3 multiplied by 24 subtract 15 is equal to 27. Well, that would make 3 multiplied by 24, take away 15, so we have multiplied by the absolute value of 9 is equal to 27. The absolute value of 9 is 9, so we have 3 multiplied by 9 is equal to 27, and when we do the multiplication, we get 27 is equal to 27. So that solution checks, so we know that x equals 24 is one of our solutions. Now let's do a check of the other solution, x equals 6. So again, we're going to take the original absolute value equation, 3 multiplied by the absolute value of, instead of x, we're going to have 6 take away 15, 6 take away 15, absolute value of that is equal to 27. 6 take away 15 is a -9, so we have 3 multiplied by the absolute value of -9 is equal to 27. The absolute value of -9 is 9, so 3 multiplied by 9 is equal to 27. And when we multiply these two numbers together, we get 27, which is equal to 27. So that solution also checks. So the two solutions for that absolute value equation are x equals 24 and x equals 6. In this next example, it says, solve the absolute value equation, check your solutions. We have the equation, absolute value of the quantity 2x add 8, added to 5 is equal to 0. Again, we want to isolate the absolute value expression. To do that, we have to undo this add 5. So we can subtract 5. And using the subtract property of equality, we subtract the same amount from both sides of the equation. Okay, when we do that, we can write that absolute value equation as the absolute value of 2x add 8 is equal to negative 5. Now, one thing I want to point out, and one thing that we need to remember, is that the distance from this 2x add 8 to 0 is a negative 5. That's what this is saying. But distance cannot be negative. There's no such thing as a negative distance. So whenever you run into a situation where you have an absolute value expression that's equal to a negative, then by definition that can't happen because you can't have a negative distance. So this would be an example where there is no solution. So because there's no solution, there are no solutions to check for this example. Okay, let's take a quick look at this next one. Solve the absolute value equation, check your solutions. Our absolute value equation is the absolute value of the group C subtract 12 is equal to 2C subtract 10. So let's go ahead and, well, we don't have to isolate the absolute value expression because it's already isolated, so we can go ahead and just write this out as C subtract 2 is equal to 2C subtract 10, and we can say that the opposite of C subtract 2 is also equal to 2C subtract 10. Now we're going to look at each of these equations one at a time, starting with the equation on the left. As we look at that, let's see, it looks like we can subtract a C from both sides using the subtract property of equality. When we do that, we get negative 2 is equal to C subtract 10. Now in order to undo the subtract 10, we can add 10 to both sides. A negative 2 add 10 is 8, so we get 8 is equal to C. So we're going to hold on to that solution here. Let's take a look at the other side. So we have a negative in front of this group, C subtract 2 is equal to 2C subtract 10. So then that means that the opposite of this negative is C subtract 2. So we're just going to write that group without the negative. But then on this side, we have to write the opposite of everything on this side. So that's negative 2C add 10. All right, now I've got a negative 2C here. It's additive inverse is 2C. So let's go ahead and add 2C to both sides. And when we do that, C add 2C becomes 3C subtract 2 is equal to, we have our 0 pair here, so what's left on this side is now 10. To undo the subtract 2, we can add 2. And using the addition property of equality, we do the same thing to both sides. That gives us 3C, our additive inverses make 0, is equal to 12. Now, if 3 C's are equal to 12, then to find the value of a single C, we just divide the 12 up into 3 groups. So dividing both sides by 3, 3 divided by 3 is 1. So we get C is equal to 4. Okay, let's do a quick check of each of those solutions. So we take our original absolute value equation. So we'll have the absolute value of 8 subtract 2 is equal to 2 multiplied by 8 subtract 10. 8 subtract 2 is 6, so we have the absolute value of 6 is equal to 2 multiplied by 8 is 16, and we're subtracting 10. The absolute value of 6 is 6 because 6 is 6 units away from 0, and 16 subtract 10 is also 6, so we can say that 8 is a solution. Now let's check this side right here. Okay, so we're going to take our original equation. So the absolute value of, in this case, is going to be 4 subtract 2, is equal to 2 multiplied by that c value of 4 subtract 10. 4 subtract 2 is 2, so we have the absolute value of 2 is equal to 2 multiplied by 4 is 8 subtract 10. The absolute value of 2 is 2, because 2 is 2 units away from 0. 8 subtract 10 is a negative 2. And as we look at that statement, that's not correct. 2 is not equal to negative 2. So in this case, the solution 4 does not check. So we're going to say that the solution to this absolute value equation is just 8.